All right, welcome to our live conference. So I'm going to get started. Remember, if you have any questions, to just type them into our chat box and I will answer those questions. I will just get started by answering some questions. So I'm going to answer the 11.1 question 2. So it says, which survey illustrates an example of qualitative data? Check all that apply. So remember that qualitative data has to do with qualities, things that are not having to do with numbers. So like characteristics of something. So when it has to do with time and minutes it took a student to finish the exam, that's quantitative. That's something that can be measured. The eye color of students involved in after-school activities. So that would be qualitative because it has to do with a quality, eye color, of a student. The characteristics of different types of birds, again, this would be qualitative because it has to do with the characteristics, that keyword there. It doesn't have anything to do with numbers. The scores on the last exam, that would be quantitative because it has to do with numbers. The weight of different books, quantitative because it has to do with numbers. Then I'm going to move on to (11-1) question 6. So it says the survey of 9th and 10th graders with siblings. So which statements are correct about the two-way table? Check all that apply. So this one says the survey represents qualitative data or quantitative data. No, this has to do with having siblings or not having siblings. There is a greater percentage of 10th graders who do not have siblings than 9th graders who do have siblings. That is a true statement because if you look at 9th graders that do have siblings, it's 52. Or I'm sorry, 10th graders that do have siblings, it's 52. And then do not 23, and then 17. So that would be greater. And then the total number of students in the poll who have a sibling is 16. So siblings and having a total would be 116. There are more 9th graders that were polled than 10th graders. The total for 9th graders was 81. The total for 10th graders is 75. Remember, if you have a question, to just type it in the chat box and I will answer that question. Okay, assignment 11.3, question 7. So 11.3, question 7. All right, so this one, says determine association. So it says the table below shows the conditional relative frequency of a set of data comparing gender and whether the academic scholarship was earned. All right, so it says which conclusion can be drawn from the table. All right, so it says that an association cannot be determined because 0.47 is close to 0.52. So when it has to do with an association, you want to be able to, it has to have a larger percentage, and it has to be like, for example, if there was an association, it would be like 0.97. There would be a larger gap. 0.47 and 0.52 are too close together to determine whether or not there is an association. So it wouldn't be there is an association between gender and a scholarship earned because each row adds up to 1. No, it should always add up to 1 no matter what, even if there is an association. An association cannot be determined because 0.47 is close to 0.53. So this has to do with earning a scholarship. This has to do with not earning a scholarship. So that's the wrong number. So it should have been scholarship here. We're looking at 0.47 and 0.52. Otherwise, you're just looking at males when it comes to this data right here. There is association between gender and scholarships earned because each column's total is the average of the values in the total. So there isn't an association because they are too close together and you're looking at male and female. If there's any other question, just ask. I will just answer another question from this topic. In the meantime, we'll go and answer a question. Let's just do question 4. So it says the conditional relative frequency was generated using the data that compares the number of boys and girls who pack their lunch or buy lunch from the cafeteria. 35 girls and 50 total boys were surveyed. How many students brought their lunch from the cafeteria? Round to the nearest whole number. So here what we're going to do is that we're looking from cafeteria, and we're looking, this is going to be 0.42 of our total. So what we can do is take the 0.42 and multiply it by our total amount. So our total amount was 35 plus 50, which would be 85. So there was a total of 85 students. And then we would multiply that by the 0.42. And that is where we get 35.7, which we can't have 35.7 students, so that's why it is 36. And then I see that you want me to answer 11.1 question 6, so I will go to 11.1 question 6. And that's this one right here. All right, so this has to do with which type of, which statements are correct about two-way frequency tables. So you're going to be looking at the data here, and we're going to be determining whether or not this is qualitative or quantitative data. So this has to do with qualitative data, not quantitative, because it has to do with you either are yes you have a sibling or no you have a sibling. It's not having to deal with the number of. It's not like, oh, you have 5 siblings or 6 siblings. So it would not be this one here. Then it says there is a greater percentage of 10th graders who do not have siblings than 9th graders that do have siblings. Right. So we're going to look at 10th graders who do not have siblings. There's 23. And then there are 17 9th graders that have siblings or do not have siblings. So this would be a true statement because there are more 10th graders that do not have siblings than 9th graders. The total number of students in the poll who have a sibling is 116. So we're going to look at the column that has a sibling. We're going to go down to its total, which is 116. Then we are going to look, okay, 52 10th graders were polled. No, the total 10th graders is 75, so that is not a true statement. There were more 9th graders than 10th graders polled. Okay, the total of 9th graders was 81, and the total of 10th graders was 75. So there were more 9th graders than 10th graders that were polled. All right, I'm going to answer some questions from 11.2. If you do have any other questions, go ahead, type them into the chat. So we're going to go to 11.2. I'll just answer this first one. Okay, so it says a group of 100 students were asked if they studied French or Spanish in school. The results are shown in the two-way table. All right, so which statements are correct? Check all that apply. So we're going to look at, okay, 5 students studied both French and Spanish. Okay, so let's look. So we're looking at French and Spanish. That would be 5 students. That is a true statement. Then there were 63 students who studied French. So we're going to look at the French column and we're going to look at the total. So no, there was 35. 2 students studied neither French nor Spanish. Okay, so not French, not Spanish, 2. So that is a true statement. 30 students studied French but not Spanish. Okay, so we're looking at French but not Spanish. So that would be 30, and that is a true statement. 63 students studied Spanish. So we're looking at the total of Spanish, and that would be 68. So no. Okay, I'll answer one more question from the 11.2. All right, so I'm going to go to question 3 here. So it says a summer camp has 32 campers. A total of 22 of them swim. 20 play softball and 5 do not swim or play softball. So they have our columns here. Our total for swim is 22. Our total for softball is 20. And we have 5 that do not do either. And our grand total is going to be 32. So now it wants us to determine the other values. So the best way of doing this is to work backwards. You want to look to see which area has the most information. So our total here, grand totals here, has only one item missing, D. So I can take 32 and I can subtract 22, and that will give me 10. So I know that D would be 10. And then that helps me figure out this row now, because we have a total of 10. There are 5 that do not play softball nor swim, so we can find the ones that play softball but do not swim is also 5, because 5 plus 5 is 10. We can figure out this one here as well because of it having only one missing. So 32 is our grand total. We have 20 that play softball, so 32 minus 20 would be 12. Then this helps us figure out our last two. So we can figure out A by taking 20 and subtracting 5, which would be 15. We can find B by subtracting 12 minus 5, which would be 7. So that is why we have 15, 7, 5, 10, and 12. Okay. I will answer another question from this section. I'm going to go on to question 6. The following two-way table represents data from a survey asking students whether they have visited Alaska, Hawaii, or both. So it says this has to do with relative frequency. So what is the relative frequency for students who have been to Alaska? Okay, so we're looking for have been to Alaska. So we're going to take our Alaska and we're going to take the grand total, because these are all the students that have been to Alaska, and we are going to put it over our grand total, which is 50, and that's why it's 14 out of 50. Then we are looking at what is the relative frequency for students who have been to Hawaii but not Alaska. All right, so we're looking for Hawaii, but not Alaska. So that's 15. We're going to put that over our grand total, which is 50. So 15 over 50 would be our relative frequency. Then what is the relative frequency for students who have not been to Alaska or Hawaii? So we're looking for not, which is 21, and we're going to put that over our grand total, which is 50. Okay, so now I'm going to be moving on to 11.4. All right, so 11.4, question 2. So consider the data shown below. So we're going to be making a histogram of the data. So it already gives us our intervals here. We have to determine how many of each item are in each interval. So between 40 and 43, we have 1, 2. So this will go up to 2. Between 44 and 47, we have 1, 2, 3. Between 48 and 51, we have 1, 2, 3, 4. Between 52 and 55, we have 1, 2, 3. And between 56 and 59, we have 1. So this would be our histogram. And then, so that means that we have 3 pieces of data that are in between 44 and 47. We have 4 pieces of data that are in between 48 and 51, and we have 1 piece of data that's in between 56 and 59. And this is pretty much symmetrical. So this would not be a skewed data. I'm going to go to question 6. So the data set 8 has provided here. As it says, use the histogram to answer the question. It says, what type of distribution? Okay, so our types of distribution that we have here, we can have skewed or symmetrical. So a good way of doing this is to draw like a line over the data, like so. If the data has like a tail, that means it's going to be skewed. If it pretty much everything is in the center and it creates like a bell shape like this, then it would be symmetrical. So because this has a tail, it's going to be skewed. And it's technically left skewed because the tail is on the left. All right, then it wants us to find the mean. So our mean is going to be, we can add up all of our numbers and divide by how many there are. So if we add, or you could type the data set into our calculator and it will provide the mean for you. So, and that's our statistics calculator. So if we were to add up all of our data and divide by how many numbers there are, our mean would be 81.071. All right. The median is the number that's in the middle. So if we were to list all of our numbers from order from least to greatest and find our middle number, it would be 83. Or you can enter the data into the statistics calculator and it would give us the median. And then it says which measure of center is best choice for this set of data. Because it is skewed, the median is always the best choice for the center. If it was symmetrical, the mean and the median are usually the same, so it would be the mean. Okay, I'm going to move on to 11.5, box plots. All right, so constructing a box plot. I'm going to do 11.5 question 5. So Charlie wants to analyze his last 9 math scores with a box plot to see how spread apart they are. Arrange the scores in order from lowest on the left to highest. Okay, so what we are going to do is first put our scores from lowest to highest like it wants us to do, and then we are going to make our box plot. So our lowest score is going to be 80. Then we are going to have 84. Then we are going to have 86. Then we're going to have 87, 90, 91, 92, 94, 94 right down there. I should have been marking this off. And then 100. All right, so then we need to find our median. So I'm going to find my median. So it's going to be 90. Is that 1, 2, 3, 4? 1, 2, 3, 4. Yes, 90 is going to be my median. So that's going to be the middle of my box plot is going to be 90. Then we need to find the upper quartile. So that is going to be we're going to cross off 90. It's going to be in between 92 and 94, which would be 93. Would be my upper quartile. And we'll do the same thing for our lower, which would be between 84 and 86, which would be 85 would be our lower. And then our lower extreme is 80, and our upper extreme is 100. And then that would be our data set. All right, and it says, what is the range of the scores? So if we were to find the range, we would take 100 and subtract 80, which would be 20. The median is 90, and then it says, what is the interquartile range of the scores? So our interquartile range has to do with the range between the upper quartile and the lower quartile. So we're going to take 93, and we're going to subtract 85, and that is how I get 8. Okay. So let's do question 8. So a basketball player records her points for 11 consecutive games. Her points are listed below: 13, 20, 15, 2, 22, 24, 21, 18, 20, 25, 17, and 27. How many points would she need to score in the 12th game in order to decrease the interquartile range by 1 point? All right. So first what we need to do is find our interquartile range. And then we can test out each of our data to see which one would lower our interquartile range. So what I need to do is list my data points from lowest to highest. So I have my lowest is 13, then 15, 18, 17. 17, 18, 20, another 20, 21, 22, 24, 25, and 27. All right, so we're going to find our median, which is the middle number. Which will be 20. Then we need to find our upper quartile value, which will be 24, and our lower quartile value, which will be 17. So this is going to help us find our interquartile range because we'll subtract our lower quartile, which is 24, or upper quartile, I'm sorry, minus our lower quartile, which will be 17. So 24 minus 17, which will get 7. So our goal is to have our interquartile range to be 6. So what we have to do is add values in here so that it changes our value. So if I were to do this, I could add in, I would start off by adding in higher numbers and then working lower. Because if we add in a lower number, we want to, that's going to move our data to the right. So let's try, we could just substitute each value into our data set and see how it affects the data. And then see which one works. So if we were to plug in another 13 here, let's just say, let's change up our colors. So this is going to be a 13. So that changes our median actually to the be in between 20 and 20, which will be 20. And then if we were to find our lower quartile, then could be here, there. It would be in between 15 and 17, which would be 16. And then our upper would be 23. And then 23 minus 16 is 7. So that is the same. So we would do that again by plugging in 15, do that again, plug in 23, and we will find that 23 works. So if we see when we plug in 23, so 23 would go here. So we won't have the 13 there. And then our median would be here in between 20 and 21, so 20.5, and then our upper quartile would be in between 23 and 24, so 23.5, and our lower then would be in between 17 and 18, so 17.5. And then 23.5 minus 17.5 gives us 6, which is 1 less than the interquartile range. So that is why 23 is the answer. Remember, if you have any questions, that you can send me a message on Edgenuity, you can email me, or call me.